We're going to talk about the trig functions of sine and cosine. Both of these functions act on an angle. So an angle goes into the function and out comes a trig ratio, which is the ratio of either the sides of a triangle, or we can think of those as XY ratios. But before we get into all of that, we're going to talk about the unit circle and how to work with values on this unit circle. Let's go ahead and start in with part B, the unit circle. So first of all, the unit circle is a circle with radius 1. And you can see that I've got it on a coordinate system here. I've got my x-axis and my y-axis. And I can go ahead and label these points as I move around the circle. Well, this point here has an x of 1 and a y of 0. The point here on the positive y-axis has an x of 0 and a y of positive 1. And then as I move my way around, x here is negative 1, y is 0. And then finally here, I've got an x value of 0 and a y of negative 1. So I can start to work through and grab these points for these different angles. So if I'm going to go to 90 degrees, I start at the positive x-axis, and I'm going to travel counterclockwise 90 degrees to get to that square corner. 90 degrees. The point on my unit circle is that point 0, 1. X is 0, y is 1. Next, I want the point at negative pi. Well, pi is halfway around the circle. This is in radians, but I'm going clockwise now. So this is negative pi, and it lands me on this point right here, which is negative 1 for x and 0 for y. Next, I want the point in quadrant 1 where x is equal to 1/2. Let's go ahead and label these quadrants. I start by labeling my quadrants in the upper right. This is quadrant 1. All my x's and y's are positive, so every point has positive coordinates. Moving around counterclockwise, I get to quadrant 2. In quadrant 2, my x's are negative, but my y's stay positive. And then quadrant 3, everything is negative. Both the x's and the y's are negative. And then finally, quadrant 4, labeling that last one with our Roman numerals, I'm back to positive for x's, but now I've got negative still for y's. Let's go ahead and do this one. The point where x is equal to 1/2. Well, x is equal to 1/2. Let's see if 1 is all the way to the unit circle. X is equal to 1/2 at about here. I want to find the point on the unit circle. So I'm going to go ahead and line this up. The point on the unit circle gives me a y coordinate over there. I can actually draw a triangle here that I'm going to use to solve this. My triangle, if I go ahead and take it off of the unit circle, has 1/2 for the x leg. I don't know what the y leg is, but the hypotenuse happens to be that radius. So the hypotenuse is equal to 1. We can use the Pythagorean Theorem. A squared plus b squared equals c squared. A squared, that's going to be 1/2 squared, plus y squared is equal to 1. This gives us 1/4 plus y squared equals 1. So y squared is 1 minus 1/4, which is 3/4. I'm going to go ahead and take a square root. So I technically get plus or minus when I'm working this through, but I'm in quadrant 1 where everything's positive. So I'm going to go ahead and choose the positive. So I end up with y is equal to positive radical 3, and I can take the square root of 4. So that's going to be radical 3 divided by square root of 4, which is 2. Let me go ahead and put that here because it's hard to read. 1/2 comma radical 3 divided by 2. Let's go to the next one. So in the next one, I've got a point in quadrant 3 where x is equal to negative 1/4. So in quadrant 3, let me go ahead and draw my circle here. Quadrant 3, I am where all of my coordinates are negative, both the x's and the y's. Negative 1/4 for the x is about right here. I want to line that up to a y. This is like a really skinny triangle, so let me pull it off here. So I end up with this guy. I've got negative 1/4 there. I don't know what y is, but again, the hypotenuse is equal to 1. So using the Pythagorean theorem, I can say negative 1/4 squared plus y squared is equal to 1. It's going to be 1/16 plus y squared is equal to 1. So y squared is 1 minus 1/16. That would be 16 sixteenths minus 1/16. So that's 15 sixteenths. I'm going to go ahead and take a square root. So it's plus or minus the square root of 15 over 16. But I'm in quadrant 3 where everything's negative. So I'm going to choose the negative. I can't take the square root of 15, so I'm just going to leave that. But the square root of 16 is 4. This is my y-coordinate. So my point is negative 1/4, comma, negative, because I'm in quadrant 3, radical 15 over 4. So we've looked at points on the unit circle as lengths on these triangles. So I've got that really nice relationship between the Pythagorean theorem and points on my unit circle. This is going to help us to find the sine and cosine functions. The sine and cosine functions, and really all trig functions, work on an angle. So for example, the sine, which we abbreviate SIN, which is kind of goofy, but we do, an angle goes inside of the function, and then out comes a ratio or fraction. The ratios change depending on what function we're using. So on the unit circle, remember our radius is equal to 1. The sine of some angle theta is always going to give us our y coordinate back. We could write that as y over 1, which is the fraction, or we could write that as just y. Cosine is always going to give us back the x coordinate. So cosine of theta is going to give us back the x coordinate, and the ratio would be x over 1. But since that radius is equal to 1, we can write that as just x. Now let's do this on a generic circle of radius r. So if my radius is equal to r, things change. So as I'm looking for these sines and cosines, I go ahead and just draw. This would be r now, x and y. And I want to do the sine of theta. I still want y, but now that denominator is no longer 1. It's equal to my radius r. And I can do the same thing with cosine. So cosine theta, I still get the x, but now it's divided by that radius of r. So this defines the sine and cosine functions. We're going to go ahead and just start off with the unit circle and deciding which quadrant each of these lies in. So I'm going to label this again. This is quadrant 1, 2, 3, and 4. Sines and cosines refer to the x and y coordinates. So I'm also going to label the signs of the coordinates. In quadrant 1, everything is positive, positive, positive. In quadrant 2, my x's are now negative. So I've got negative, but my y's are still positive. In quadrant 3, everything's negative. So negative, negative. And then in quadrant 4, I'm back to positive x's. So positive, comma, negative. This is going to help us get through this problem. So I know that all of these signs refer to my y coordinates around the unit circle, and all of these cosines refer to the x coordinates. I just need to decide which quadrant they're in based on their sign. So for the first one, it says that the sign is greater than 0. That means that it's going to be positive. So this is y is positive. Cosine is greater than 0. This one's also positive. So both of my coordinates are positive. That means I want quadrant 1. So positive, positive gives me quadrant 1. For the next one, sine is less than 0. So this means that my y coordinates are negative. That gets me to either of these two lower quadrants where the sign is negative. Cosine, though, is positive, so my x's are positive. So I want negative y's, but positive x's. That's going to put me right here into quadrant 4. So quadrant 4. Next, sine is greater than 0, so y is positive. Cosine this time is negative, so x is negative. So I want negative x's, but positive y's. There they are in quadrant 2. And then finally, sine is negative, so y is negative, and cosine is negative, so x is also negative. This must be quadrant 3, where all of our coordinates are negative, quadrant 3. Okay, next, we want to use the unit circle to answer the following. So I'm going to go ahead and give myself a picture here of the unit circle. kind of, sort of, right? This is my x-axis and my y-axis. And I'm going to go ahead and start to move around the unit circle with these values. So this first one says that the cosine of 0, we want to know what it is, cosine of 0 degrees. So that means I'm right here. I have not left the positive x-axis. I am on the unit circle. So that means that I can just go ahead and grab whatever the x-coordinate is. Well, this is at 1, 0. The x-coordinate is equal to 1. So remember, cosine are your x's, sines are your y's. And I memorized this in kind of a goofy way. Sine sort of rhymes with y, so that helps me remember that the sine are the y's and the cosine are the x's. Now, these are all called quadrantal angles, and they're called quadrantal angles because we're going to land on an axis, either the x or the y-axis. Same is true with 270 degrees. So if I travel now from the positive x-axis, 270 degrees, I land here. On the unit circle, I'm at this point. At that point, I have x is 0, and then y is -1. So for 270 degrees, my y, let's do my x, cosine. So cosine of 270 is going to be 0. Let's also backtrack and do this one. That way we can do point by point. If I go back to 0, I've got my x and my y. So the sine of 0 is equal to the y-coordinate, which is 0. So sine of 0 is equal to 0. Now I can go to the 270 degrees. I just grab the point at 270. X is my cosine, y is my sine. So this time y is going to be -1. Now let's travel to pi. So if I travel to pi, I'm over here at this point, and this point has x of -1, y of 0. Cosine is my x coordinate, so x and y. X is -1. Sine is my y, so that's going to be 0. And then last but not least, pi halves. So pi halves, I'm going to land right here. This point, I've got 0 for y and 0 for x and 1 for y. So if I want the cosine, that means that I want the x coordinate, which is 0, and the sine, I want the y coordinate, which is 1. Okay, next. If theta is in quadrant 2, and cosine is equal to 1/2. Now remember, we're still on the unit circle. These are actually a lot like the ones that we did at the last part of one of the problems on the first page. Okay, here's my circle. Cosine is equal to 1/2. That's my x coordinate. So my x is 1/2. I'm in quadrant 2. Let's change this to quadrant 1 because that wouldn't make sense. So I'm in quadrant 1. Don't change this. This should already be changed on your worksheet. So x is cosine. So x is 1/2. I want to figure out what sine is. Well, I know that sine is going to be this y coordinate right here, the y that I line up with, y. So I have this triangle. I can use the Pythagorean theorem. I'm on the unit circle, so the hypotenuse is 1. My x length is 1/2, and I've got my y there. I'm going to go ahead and use the Pythagorean theorem. I think we did one just like this before. So I've got 1/2 squared plus y squared equals 1 squared. So y squared is 1 minus 1/4, which is 3/4. So y is plus or minus the square root of 3/4. I'm in quadrant 1, so I'm going to choose the positive y, and I get radical 3 over 2. So sine is that y that we just solved for. So sine is radical 3 over 2. Next, we are in quadrant 3. Sine is -1/8. So let me draw myself another picture here. I'm in quadrant 3, where all my coordinates are negative, negative, negative. Sine is, so that's going to be my y value is -1/8. So I'm right here. I want to line this up to the unit circle. So I end up with this triangle. So my triangle looks like this. 1 on the hypotenuse. -1/8 is my y coordinate, and I'm going to solve for my x coordinate. That's going to give me my cosine. So I go ahead and do the Pythagorean theorem. X squared plus -1/8 squared is equal to 1 squared. So x squared is 1 minus 1/64. That's going to be 63/64. I take a square root. X is plus or minus the square root of 63/64. Square root of 64 is, let me give myself a little more room here. Square root of 64 is 8. I'm going to go up here. I'm choosing the negative, so negative over 8. And I can break that 63 down. If you're not good at breaking down square roots, go ahead and just take whatever that number is that you're trying to take a square root of and start dividing in perfect squares. Well, 9 happens to go in there 7 times, and 9 is one of my perfect squares. So it's 9 times 7. I can go ahead and take the square root of 9. So I get negative 3 radical 7 over 8. So we end up doing quite a bit of algebra here. So the cosine is this x that I just found, and that's going to be negative 3 radical 7 over 8. So it turns out that it's not the sine and the cosine that give us some additional steps and some challenges. It's really the algebra of applying the Pythagorean theorem. But really what I want you to take away from this part is that cosine are the x coordinates on the unit circle, and the sine refers to the y coordinates on the unit circle.